Chapter 6, Section 4, The Nature of Sound. The two main questions: what is sound? What factors affect the speed of sound? What is sound? Here is a riddle. If a tree falls in a forest and no one hears it, does the tree make a sound? To a scientist, a falling tree makes a sound whether someone hears it or not. When a tree falls, the energy with which it strikes the ground causes a disturbance. Particles in the ground and the air begin to vibrate or move back and forth. The vibrations create a sound wave as the energy travels through two mediums, air and the ground. Sound is a disturbance that travels through a medium as a longitudinal wave. Making sound waves. A sound wave begins with a vibration. Look at the drum shown in Figure 1. When the side of the drum, called the drum head, is struck, it vibrates rapidly in and out. These vibrations disturb nearby air particles. Each time the drum head moves outward, it pushes air particles together, creating a compression. When the drum head moves inward, the air particles bounce back and spread out, creating a rarefaction. These compressions and rarefactions travel through the air as longitudinal waves. How sound waves travel. Like other mechanical waves, sound waves carry energy through a medium without moving the particles of the medium along. Each particle of the medium vibrates as the disturbance passes. When the disturbance reaches your ears, you hear the sound. A common medium for sound is air, but sound can travel through solids and liquids too. For example, when you knock on a solid wooden door, the particles in the wood vibrate. The vibrations make sound waves that travel through the door. When the waves reach the other side of the door, they make sound waves in the air. Diffraction of sound waves. Have you ever wondered why, when you are sitting in a classroom, you can hear your friends talking in the hallway before they walk through the door? You hear them because sound waves do not always travel in straight lines. Sound waves can diffract or bend around the edges of an opening, such as a doorway. Sound waves can also diffract around obstacles or corners. This is why you hear someone who is talking in the hallway before the person walks around the corner. The sound waves bend around the corner. Then they spread out so you can hear them even though you cannot see who is talking. Remember this the next time you want to tell a secret. What factors affect the speed? Suppose you were in training watching a baseball player in Figure 3. Suppose you were in a stadium watching a baseball player in Figure 3. You might see the bat hit the ball before you hear the hit. It is possible to see an action before you hear it because sound travels much more slowly than light. At room temperature, about 20 degrees Celsius, sound travels through air at 342 meters per second. That is nearly 900,000 times slower than the speed of light. But the speed of sound is not always 342 meters per second. Sound waves travel at different speeds in different media. The speed of sound depends on the temperature, stiffness, and density of the medium the sound is traveling through. Temperature. In a given liquid or gas, sounds travel more slowly at lower temperatures than at higher temperatures. Why? At lower temperatures, the particles of the medium move more slowly than the higher temperatures. It is more difficult for the particles to move, and they return to their original positions more slowly. Stiffness. Years ago, Native Americans put their ears to the ground to find out if herds of bison and other animals were nearby. By listening for sounds in the ground, they could hear the herd sooner than if they listened for sounds in the air. What is it about the state of the medium, solid, liquid, or gas that determines the speed of sound? The speed of sound depends on the stiffness of the medium. Sound travels more quickly in stiff media because when the particles of the media are compressed, these quickly spread out again. For example, steel is stiffer than wood. If you knock on both a wooden and steel door at the same thickness, the steel door would transmit the sound more easily. Sound also travels better over long distances in stiff media because sound waves lose energy more slowly than in less stiff media. Solids are stiffer than liquids or gases. The particles in a solid are close together, so they bounce back and forth quickly as the compressions and rarefactions of the sound waves pass by. Most liquids are not as stiff as solids, so sound does not travel as fast in liquids as it does in solids. Gases are not very stiff. Sound generally travels the slowest in gases. Density. In materials of the same stiffness, sound travels more slowly in the denser material. Density is how much matter or mass there is in a given amount of space or volume. The more dense the material, the more mass it has in a given volume. The denser material, it is harder for the particles to move as sound waves pass by. This slows sound down. The Channel Tunnel is a 50-kilometer long undersea tunnel with a railway connecting England and France. Figure 4 shows some engineers working in the tunnel. The engineers sent messages to each other by tapping on the steel pipes. The sounds travel through the pipes at the speed of 5,200 meters per second. This is nearly 4 times faster than the speed of sound in lead. The speed of sound in steel is greater than in lead because steel is both less dense and stiffer than lead.